All right. Hello, everyone, and welcome to today's codeLive session, where we are going to talk about how you can simplify RAG for agents using a new feature called Einstein Data Library. My name is Aditya, and I work as a developer advocate with Salesforce. And my job is to make sure all of you are successful in building implementations on the Salesforce platform. So, as a part of that, me and my team, we roll out blog posts, videos, live streams like this, code samples, and a lot more to ensure all of you are successful. So before we get started, quick introductions. So like I've introduced myself. So those of you who have joined the stream, so if you can let me know who you are, where you're joining me from. I already see a couple of people. Hey, Tech Lead Cloud Consulting, you are one of our regulars along with Niket. Hi, both of you. Then good evening, Naresh. Hi, Asad from Dubai. We've recently been in Dubai for Dubai Dreamin'. It was a wonderful conference and a wonderful city. It was my first time. And hey, Ram, how are you? So I guess people are joining us from all over the globe. And thank you all for joining. This is, I think, the third live stream that we are doing in the last 2 days. So we had an Agentforce workshop on Apex Hours, and then we had an AMA, and this is the third live stream. I guess next week is Thanksgiving, right? So all the live streams we are trying to wrap it up so that all of you can have a nice holiday. Hey Eric, welcome to the stream. Hey Annappa. So we will get started, and I'll keep looking at the chat occasionally to see if you have any questions, and we will take it from there. All right. So before we get started, forward-looking statement. Please make all your purchasing decisions based on generally available information and not based on anything that I might say today. So with that out of the way, let's get started and see what we are going to learn today. So first of all, we are going to learn about RAG because it's a new concept. I want to ensure all of us are starting from scratch. So we'll understand what RAG is about, and we will see how you can set up RAG using Data Cloud. And once we do that, once you have an understanding of how things work, then we are going to learn about data libraries. And then we will see how you can set up RAG with a data library. Essentially, see the difference between an implementation that doesn't use a data library versus an implementation that uses a data library so that you're clear on when to use what. So that's going to be our agenda for today. We'll try to wrap this up in the next 30 to 40 minutes. And we'll anyways have time for Q&A. So the very first question is, what is RAG? So RAG stands for Retrieval-Augmented Generation, and it's actually a process to ground your prompts in the latest data and information. So that's what I've put on the slide. But why is RAG important? So whenever you think about AI, at the heart of it is going to be an LLM, a large language model. And these large language models are typically trained on a large data set. And this training is an expensive process, and it can take a lot of time to train all of this data. But then if you have been working with databases, if you've been working with data, you're generating a lot of data on a day-to-day basis. So you know that data is not constant and data evolves all the time. So each time the data changes, are you going to retrain the model? The answer is no, because like I said, it's expensive and time taking. So RAG is a technique where you take a pre-trained model, and whenever you're asking a question, you actually supply along with the question the latest data that you have. So that is what we call augmenting a prompt. So along with the data the LLM already knows about, you're actually supplying your own set of latest data to the prompt so that the LLM can generate an effective response based on the latest data. Now, when it comes to Salesforce, none of the LLMs are trained on your enterprise data, and they're never going to be trained on your enterprise data. So RAG is effectively that technique where you take an LLM and along with your prompt, you supply your enterprise data that is relevant to generate a response for that prompt. So all of this technique is called as RAG. And when you talk about data, there are two kinds of data that you deal with. So either it is structured data or unstructured data. Now, when you talk about structured data, it is any data that resides in a tabular format. You have rows and columns. So that is what we call structured data. And typically, most of the data that you store in Salesforce, like your standard objects, custom objects, most of it is structured data. But then structured data generally in the whole data space, you can consider it to be only the tip of the iceberg. Because if you take any organization, unstructured data makes up about 80% of what data they have. Like this data can include documents, which are either in PDF formats, Word documents, or you can have chat transcripts. You can have video files, you can have audio files, pictures, so on and so forth. A lot of information that is relevant is not actually stored in tabular format. Now, how can you work with this? How can you ensure you're augmenting your prompt with both structured data and unstructured data? So that's a problem that we have solved using Data Cloud. And before we even talk about structured data, unstructured data, how you ingest all of that data, what is important to understand is once you have all of this data in one place and you need to augment a prompt with that data, you actually need to search and only put in the relevant data into the prompt. Now, for example, if you want a summary of a case, then you query the case data and then you put that case data into the prompt and it's going to then summarize it. Now, how do you query a case? So maybe you queried based on the case number or you queried based on the record ID. Because it is in tabular format, it's very easy to query. But how do you query something that is present in a PDF file? Or how do you query something that is there in audio or video format? How are you going to know what is relevant and what is not out of a big PDF file? So that's where different search mechanisms come into picture, where the first search mechanism is known as a keyword search, which matches exactly based on the word. For example, if you're retrieving a case by the case number, then we do an exact match with the case number and pull in the data. So that's a keyword search. Now, what are the pros? Of course, you can match exactly based on the keyword, but one of the cons is you don't match on the meaning of the word. Now, why does that become relevant? Now, when you talk about the example that I told you, where you're only searching about records, then more likely you're going to be using a filter condition, and that's okay if you're matching based on the exact word. But let's say you have the content stored, let's say in a knowledge article, or maybe a chat transcript or a PDF. So there's a lot of data present in these kinds of knowledge bases. And whenever you want to search through that, the end user doesn't necessarily need to search based on the exact word. Because let's say today we are going to be using the example of a resort called Coral Clouds. And in order to get to a resort or a hotel, think of any use case where you're traveling somewhere. What are the different modes of transportation that you have? If you have that simple question, how do I get to a place? You can either take a flight, or you can take a train, you can take a bus, or you can take a car. Or in the case of Coral Cloud Resorts, you can take a boat. Now, when a user is asking a question, they need not specify the same term. Maybe you have a document that says, how do you get to Coral Cloud Resorts? In that, you say, take a flight. But then a flight is very similar to the word aeroplane. So what if I search, can I take an aeroplane to Coral Cloud Resorts? Now, if I search based on the keyword, I will not get any results back because none of my data contains the word aeroplane, but it contains the word flight, and both of it mean the same. So that's where vector search is going to come into picture, where you're going to search by the meaning of the word and not the exact word. So if I search based on the word aeroplane, I'm going to get the results back that include the word flight as well. So that's something that we need to know about the different search mechanisms. And inside Salesforce, we offer both these search mechanisms, keyword search or vector search. And most importantly, we give you the best of both worlds, where we offer hybrid search as well, where the moment you run a search, we search both based on the keyword as well as based on the meaning of the word, so that you get the best results possible. Now, why am I explaining all of this to you? Is because you need to understand what goes behind the scenes whenever you're trying to search for something and whenever you're trying to augment your prompts with the relevant data. Now, to make all of this happen in your mind, maybe this is complex, but that is where Data Cloud comes into picture. So, as you know, Data Cloud is that tool that lets you ingest data from multiple sources and create that single source of truth. And what's new here, I mean, it's been there for some time now, is that along with the structured data, you'll also be able to ingest unstructured data into Data Cloud. Now, once you ingest this unstructured data, let's go back to structured data for a minute. So when you ingest structured data, what you typically do is you get it using a data stream and you map all of that data to a harmonized data model, and then you use it further along. Now, when it comes to unstructured data, it doesn't quite work that way because there are a few mechanisms that are built into Data Cloud that support the concepts that I just described. Now, the first concept I described is how do you search through, for an example, let's take a PDF. So let's say you have a huge PDF that you have ingested into Data Cloud. The first step that we are going to do is we are going to chunk that PDF, which means we will divide it into logical segments, like each paragraph will become a chunk because it makes it easy to search through different chunks instead of a big PDF. Now, once I have divided my unstructured data into little bit chunks, which contains a lot of text, I can run a keyword search because it is text to text matching. But how do I do this semantic search? How do I search by the meaning of the word? So for that, what we do is we put these chunks into what we call an embedding model, and it generates a sequence of numbers, which is also known as vectors. Now, it is important that you convert text to this vector format, a process that is also known as vectorization. And you do this because once you convert a word into a numerical format, you'll actually be able to search using the meaning of the word because it is now in a numerical format. Now, why is that possible? How is that possible? Is actually a pretty complex topic. And as Salesforce developers, we need not worry too much about how the internals of vector search work. But just know that the first process is chunking, that is dividing it into different logical segments of text, and then converting that text into a sequence of numbers to enable vector search. So now that you have that sequence of numbers, you'll be able to run a query against those numbers and get the text that you want. So all of that is taken care by Data Cloud. And this search you can run from anywhere that you want. Let it be Agentforce, let it be Apex Code, Flows, wherever that is. Now that's how all of this happens at a very high level. But when you as a developer or an admin, you go ahead and set it up on Data Cloud, what exactly do you need to create? Like what is the terminology inside the app that you need to know in order to set this up? So the first step is to actually ingest data where you will be creating a data stream. So most of you should be knowing this if you have worked with Data Cloud. You create a data stream to get unstructured data and put it into Data Cloud. Then the next step, which is the vectorization that I talked about, the chunking and vectorization. In order to do that, within Data Cloud, you create what we call a search index. So within Data Cloud, there is a tab. It's just point and click. You need not, all the process that I described, again, like it might seem complex, but if you try to set it up in Data Cloud, it is quite easy. It's just point and click for you to set up what we call a search index. Now, once you create the search index, it's going to convert your PDFs or whatever documents into that sequence of numbers. Now, that is step one. And this can happen at any time you want. This is like a one-time thing where you get all your documents converted into a sequence of numbers. Now, step two is how do I access this? Now, how do I query against this sequence of numbers? Or how do I query existing structured data? And how do I augment my prompt with all of this data? So that is where this RAG comes into picture, where the first step is to retrieve. Now, in order to retrieve this information, you can write a SQL query because in the end, it's a sequence of numbers stored somewhere. So you can run a SQL query and get the results back. But this is a pro code approach. Now, what we also give you is a no code approach where we automatically create for every search index a retriever. So a retriever is a thing that actually goes ahead and queries whatever data that you want and returns the results back. And all of this happens in a no code fashion. And you're going to see how all of this works in just a bit. And then you're going to augment your prompt. So essentially, whatever data you have queried, you're going to put it inside your prompt. And then you're going to generate the results. So this prompt that you create can be invoked from, let's say, Agentforce, which is any agent can invoke this prompt template, which in turn will query your unstructured data, get the results back, and sort of give you a summary. You can invoke this prompt template from Apex, you can invoke it from flows, you can invoke it from APIs. So literally, you will be able to access this data from anywhere that you want. And this is the concept of RAG and how you set it up inside Data Cloud. Now, actually, these are enough slides. So let's quickly see this in action. So first of all, like I said, to set a little bit of a context, we are going to be working with Coral Cloud Resorts, which is a fictitious company, which is a beach-facing resort. And they have a bunch of data that is stored either in Salesforce, or in this case, they are using knowledge articles in order to store some of the frequently asked questions. And they also have some PDF files, which we're going to talk about. Now, let's say the data that you want to ingest is present in the form of knowledge articles, because knowledge articles is like a frequently used object in Salesforce to store a lot of rich information, often unstructured data, because it's all a bunch of text that you need to search through. Now, how do you ingest knowledge articles into Salesforce? So for that, you create a data stream. So we are in the data streams tab. So you click new. And because this data is already present, like in Salesforce, you choose the CRM connector and you click next. And once this populates, you'll be able to fetch in your knowledge articles using the knowledge article object. So knowledge underscore underscore KAV. And we also have a data bundle that comes for knowledge. The reason is it is not just important for you to get the knowledge articles themselves, but every knowledge article also has categories. So data categories is something that you can assign to knowledge articles. These categories are in turn grouped into what we call data category groups. So all of this data about a particular knowledge article should be fetched into Salesforce, and for that you create a data stream. Now, once you do that, the data is going to come in. Now, let's say you have a PDF file that looks like this, where you have a bunch of information about, let's say, policy cancellations, refunds, bookings, and so on and so forth. A lot of information. Like I said, 80% of any company's information is present in unstructured format. Now, let's say I have a PDF like this. Now, without a data library, I haven't introduced data libraries to you yet. But without a data library, you have to typically upload this into a cloud storage system, like let's say Amazon S3, Google, Microsoft, and so on. And what you will end up doing is this time from the data lake objects, you will click new, and you'll actually create a data lake object from an external file. And once you click next, we show all the different cloud storage providers, and you select the provider that you want and then get in the files um, from that cloud storage provider. So once you do that configuration, what you see is a bunch of data lake objects get created. For example, all the information about policies, I am fetching using this resort information data lake object. And if you notice, the type of object is going to be directory table. So directory table means it is storing some information about unstructured data. Now you have the data that has come in, whether it is through a PDF or whether it is through knowledge articles. Now the data is present in your data lake objects, which are again subsequently mapped to data model objects as well, which is a standard concept. So I'm not going to get into that. Now, once you have this data inside Data Cloud, if you remember from the slides, the second step is to actually go ahead and do the vectorization process, where you will be creating a search index. So here we have a tab called search index again within Data Cloud. And all you need to do is click the button new, and you have a bunch of different configuration options. Let's go with the easy setup. And what you need to do here is select the data model object that has to be vectorized. So the vectorization concept is not just for unstructured data. Even you can search on structured data with the meaning of the word rather than the keyword itself. So anytime you want to do a search based on the meaning, you create a search index. And most often you do it on unstructured data, but knowledge articles, for example, even though the content of the knowledge article itself is a bunch of text which is unstructured, the knowledge article schema is structured. So you will still be able to create search indexes from any data model object that you have. So what we do here is we choose the object in which our data is present and we click next. So this is the simple configuration. So there is not a lot that you get to configure. But if you're an advanced admin or an advanced developer, you can actually choose the algorithms that are used, the chunking strategies that are used. So there is a lot of stuff that you can configure. But for whoever is listening for the first time, you need not get into all of that. So essentially, you create a search index and look at what the search index creates. So once the search index runs, it creates a chunk object and it then creates an index object. So the chunk object is the one that stores all of the chunks of the PDF file in this case. And the index file stores the vector representation of those chunks. So that numerical format is stored in the index table. So whenever you want to run a search, a vector search or a hybrid search, you will be running it on the index table. Now, in case you have uploaded audio or video files, then we first transcribe it in the sense that whatever is the audio, we convert it to text, and that is stored in the transcription object. So you set this up, and then your search index gets created. And if you notice, either the status is ready, failed, sometimes it fails, so you recreate it. But this process of vectorization typically takes somewhere around 30 to 40 minutes with minimal amount of data. But the time it takes to create the search index really depends on the amount of PDFs that you have, amount of files, the size of those files. There's a lot of conditions that go into it. But just know that this is a time-taking process. So it's not something that is going to happen immediately. Now I have created this resort information and vectorized it already. So let's go ahead and look at how it looks like. So what I've done here is I have queried the resort information chunk DMO that gets created. And if you notice, I have all these PDF files that I have ingested. For example, valet policies, hotel policies, planning services, experiences, so on and so forth. And each of these PDF files have been divided into all of these chunks. So this is what happens behind the scenes. And along with chunks, if you notice, there is also an index table that gets created. You won't be able to actually see the index, that is those number representation. You will not be able to query it directly using the data explorer. But then when you run a vector search, it does go ahead and query the vector representation format. So again, to quickly recap, because there's a lot of complex concepts that we explain. First step is you ingested the files. If they are in knowledge articles, you got them using data streams. If they are in PDF files stored locally or maybe somewhere else, you uploaded them into cloud storage and created a data lake object and gotten all those files. Then we created a search index that does two things. It first chunks your data and then it converts it into a vector representation. So this was step one, where you get your data, you convert it into numbers. Now, step two, how do you actually interact with this data? So the first thing that I said is you'll be able to write a SQL query. So here is the SQL query that I have written using the query editor feature on Data Cloud, where essentially this is the table, resort information index, where your vectors are stored, and you're running a vector search. So you're running vector search on this table, And what is your question? What is the question with which it is searching your table? So that question is going to be your second parameter. In this case, what is your cancellation policy? So what do? I query it using the vector search keyword. And which table am I querying? I'm querying the resort information index table. And what is the question? I'm using the question, what is your cancellation policy? Now, once I run this query, notice the output. I'm getting a bunch of different chunks, and along with that, a score. So essentially, this is what we call a vector score, which sort of tells me how accurately does this chunk answer my question. It's kind of like Google. If you want, you can return the first 10 results and show it to the user, or you can only return the first result, or better yet, you can actually get 4 or 5 results, put it into a prompt, and summarize that together. So instead of you returning this big chunk of information, you put it into a prompt template, send it to an LLM to sort of summarize and give a nice one paragraph answer to this question. Now, this is a query that you have written. You can execute this query using API. You can execute this query using Apex and whatnot. But I also spoke about a no-code way of retrieving things. So for that, I introduced a concept called as a retriever. So a retriever is something that you can access using the Einstein Studio tab right within Data Cloud. And if you see, I already have a bunch of different retrievers. And I can go ahead and create a new retriever by clicking the new button. And what do I get to do is I get to select the data model object and the search index related to that object. And then if I want to apply some filters, I can also do that, or I can return all the documents that I want. And then what are the results that my retriever is going to send in? So most likely the information is going to be present in the chunks. So I will go and have to select the chunks that are returned as a result. Because if you've seen my query that I ran earlier, I'm asking a question, I'm getting chunks as a response. So that's what I can configure using point and click. And then I can go ahead and click save. Now I can create n number of retrievers by adding different filter conditions. So if I only want to search the documents updated in the last 1 month, then maybe I put in a retriever filter saying last updated date greater than 30 days ago or something like that. So it depends on my use case on how many retrievers that I want to create. Now, how do you access this retriever? So, like I said, you'll be able to use it in a no-code basis. And typically, you put all these results inside a prompt template in order to augment it. So here is a prompt template that I have that answers any questions that a user has. So I have a very simple prompt template over here where I give the context saying that your task is to give answers. And here is the customer's question. And please use the following information to answer the question. So if, let's say, I don't have this, what it means is this question is going to be answered based on the existing knowledge that a model has been trained on. And since this is a Salesforce use case, the model is not going to have any data about us. So it's going to hallucinate and try to answer the question in random ways. So we have to augment this prompt with the data coming in from our tables. So you're familiar, I'm hoping, if you have created a prompt template before. In the resources panel, you can ground this prompt template on record data. You can invoke flows, you can invoke Apex, but you can now invoke a retriever. So you have a new option here called Einstein search. So you click that and it's going to show up all the different search indexes that you have and the retriever that you want to use. So you just add that retriever and you configure that retriever on the right hand side, where the retriever, obviously, it's like any query engine. So it needs what it has to search. So you will pass in the search text, which is going to be the question. And in the output fields, you're going to have the chunk returned as an output into this prompt template. So pretty much no code. You add a retriever into the prompt template, pass the question to search, and specify the output field. In this case, it's going to be the chunk and the number of results to return. And now I can actually go ahead and test this prompt template. And if I go and ask, what is, maybe I say, what is your cancellation policy? And I updated it. So let me just save as a new version and preview. Now notice what happens. We take this question, we run it against the retriever. We are going to get the search results back. And if you see, we have grounded the prompt template. So the retriever is replaced with all of these different search results, which is exactly the same that you have seen in the query before. So all of it is going to come down in a JSON format. These are all the different chunks. And if you see, we have neatly summarized the whole response into a paragraph. Now, this is how we expect you to do RAG. Now, this is how you have to do RAG in order to have access to all of this unstructured data. And now that you've created this prompt template, you can invoke it from anywhere. And because we are talking about Agentforce, let me show you how you invoke it from an agent. So if I ask the same question, what is your cancellation policy to an agent, it's going to run the prompt template. Why? It's because I have actually created the prompt template as an agent action. So agent actions can either be Apex classes, flows, or prompt templates. So I have whatever prompt template I have created, I've actually created a custom agent action called policy questions. And if you notice, based on my question, that is the action that has been invoked, and the prompt response is what is shown. And notice it has all tolerated spelling mistakes as well, because it's searching by meaning and it's LLM. So it understands if I make a spelling mistake as well. Now, this is how end to end you set up a RAG implementation based on all of the files that you have. Now, let's get into the actual topic of today's codeLive, which is Einstein Data Libraries. Now, the reason I've put this towards the end is Einstein Data Library is that tool that simplifies everything that you have just seen. So instead of you doing all of the steps, whatever steps that I've shown you, you have to manually configure them. But with an Einstein Data Library, most of these steps are automated for you. So now, what is Einstein Data Library? It's a tool. It's a tool that lets you set up RAG. So all of that you have seen until now, you can set it up quite easily with an Einstein Data Library. Now, what can you upload to an Einstein Data Library? You can upload either knowledge articles or any files that you have locally. So any PDF file that is stored, you can upload it, not just PDF, by the way, it's HTML, text files, many other types of files that you can upload, not images, of course. We don't have that capability yet to parse images and look at the content of an image, but any kind of like text-based files you'll be able to upload. And of course, you can ingest knowledge articles, and both of these is supported with Einstein Data Library. Now, the moment you create a data library, we automatically create a data stream. We automatically create the relevant data lake and data model objects. We automatically create the search index, and the retrievers for that search index will automatically be set up. So all the different tabs that I've shown you until now, all of it is automatically created the moment you create a data library. Now, a data library can be used in two places. One is with Agentforce agents, and the other one is with Einstein bots. Now, let's actually see how you can use this. But before that, how does it really work behind the scenes? If you're someone who wants to dive into the schema, so you can create multiple data libraries with different files, if it is a file-based data library, or you can create a knowledge-based data library. So it's an important thing that you need to remember right now is that when you create a data library, you can either use it for knowledge articles or with files. So a single data library cannot be used to store both knowledge articles and files. You'll have to create two different libraries for that. One library for files, one library for knowledge articles. Now, if it's a file-based data library, what happens? Whenever you create a data library, we push in all of the data into a data lake object called AI grounding file ref, which in turn is mapped to the corresponding data model object. Then this data gets pushed into a new data model object called rag file UDMO, where UDMO stands for unstructured data model object. So rag file UDMO is that object in which all of your files are eventually going to come and sit in. Like I said, we automatically create a search index as well. So we create both the chunk and index data model objects based on this data model object in which your files are present. Now, a search index, we will automatically create a default retriever, which means using this, you will be able to search through all the different files. Now, what is one important thing that I think you would have noticed is irrespective of how many data libraries I create, all the files are going to be present in a single data model object. Now, what if I want to retrieve only the files that are specific to this data library? I mean, the whole reason we are creating different data libraries is to ensure we are segmenting our data. So maybe policy documents are stored in this library. Maybe driving directions are stored in this library. Now, how do I search a specific library if all the files are eventually going into the same data model object? Now, for that purpose, we automatically create different retrievers for different data libraries. So notice there are two different retrievers. I mean, this is a slide, but I'm going to show it to you in a demo as well. But eventually know that for each data library that you create, you're going to have a corresponding retriever that is created that will only search on the files of that specific data library. Even though all the files are in one common place, we create different retrievers to search based on specific filters. So to give you an example, if you are using data library 1, we use the retriever for EDL1. If you're using data library 2, we use the retriever for EDL2. Now, one other important constraint is that I told you data libraries can be used in Agentforce agents or bots. So an agent can only use one data library. So that's a limitation that we have currently, that you cannot have multiple data libraries for one agent. So one agent can only look at one data library. So which is why there are all these different retrievers in place. Now, what about knowledge-based data libraries? So knowledge-based data libraries, knowledge, given that it is there in Salesforce, remember the first screen that I showed you in the demo about data streams. So since all of these are objects within Salesforce, we are able to just get those objects and map them to the corresponding DMOs. And then a search retriever and an index is created for those DMOs. So that's how knowledge-based data libraries work. So file-based, there is rag file UDMO and the relevant chunk objects. For knowledge-based, it is the knowledge KAV object from Salesforce that gets pulled in, and it's created as a data model object. Now let's see all of this in action on how easy it is to set up a data library. Now we have two new PDFs over here. One is Coral Cloud Resort FAQs that contains FAQs in kind of like this format. And then we also have another document about their valet policy. So does Coral Cloud Resorts have valet parking and what are the policies around that? Now, what is interesting here is this policy document is in Spanish. It's not in English language. So it's a Spanish document. And what I also have in my org is a bunch of different knowledge articles. Now, one more limitation that you need to keep in mind is that if you want to use a data library for knowledge articles, then you need to have at least 10 knowledge articles that are published in your org. Only then a data library will be able to be used for knowledge articles. So here, if you see, I have more than 10, which is exactly 12 because I couldn't create more demo data. But yeah, we have 12 knowledge articles. Now, how do I create this Einstein Data Library? So previously, if you remember, we had to go through streams and all of that, and all of it is automated. So from setup, you can navigate to Einstein Data Library. And this is your Salesforce setup. It's not even Data Cloud setup. So navigate to Einstein Data Libraries. And you see I've already created a bunch of libraries, but you can click the new button, give the library a name. In this case, I'll just call it demo. And you click on save. Now, this is going to be the detail page of your data library, where you can see that you can either upload knowledge articles or a file upload. And as I mentioned, it is only one type that you can choose. For example, if I upload a file, you will not be able to choose knowledge articles. If I choose knowledge articles, I will not be able to upload a file. So it's just one or both. And again, if you want to use knowledge, you need to have at least 10 published knowledge articles in your org to be able to use this feature. Now here there is some configuration that you need to give, like what is the field that I need to be searching on. For example, if I ask a question, where do I need to search? So I can specify those fields. For example, I need to search on the title field and maybe the summary field. And when I return the results back, what do I need to return? Do I need to return the article number, any extra details that I have? So I can choose any extra fields that are sent out for this. And then you can optionally specify some filters as well. For example, only if you want to use public knowledge articles. So there is a checkbox on any knowledge article called available for public. So if you want to use only those, you will enable this filter. And if you want to filter based on data categories, what if you don't want all the knowledge articles, but only the knowledge articles that talk about FAQs? So if you want to do that, you'll be able to check these boxes and actually filter your data based on these knowledge articles. If not, you can always upload a file. So here you click on file upload, and then you can see all these different files that I have. And those are the ones that I will be able to upload to my data library. And if you notice, that's what I've already done. For example, there is this resort policies data library that I created, where I uploaded these PDF documents, like the Spanish document that I had and some other directions. And similarly, I have this FAQ only knowledge library, where I have put in the same configuration, the title, the summary, and I'm returning the details back. And in knowledge settings, I have only checked the FAQ category to be used. So I've created these different data libraries. Now, once you create this data library, I told you that all of the setup is automated in the background. So if you go back to Data Cloud, you'll be able to see all the different data streams that have been created. So for example, the knowledge data stream is created and the knowledge articles have been ingested. And this is the data stream AI grounding file ref that ingests all the files that I have. And all of these are going to be put in their corresponding data model objects. And if you notice, a RAG file UDMO is that data model object I was talking to you about, where all the files are stored. And because we automatically create a search index, you'll be able to see the chunk and index DMOs for the particular object. Same is the case for your knowledge articles. So your knowledge article version is available as a DMO, and that is something that we chunk and index. So there are chunk and indexes present for both of them as well. So this setup happens in the background. Now, what about retrievers? So if I go back to Einstein Studio and look at retrievers, you will see that there are a bunch of different retrievers that are automatically created. So there is one retriever that is created for my knowledge articles, but then there are multiple retrievers created for my files. So why is that? So there is a default retriever that searches through the entire DMO. So if you click on this, you can see it searches the RAG file UDMO object, and it doesn't have any filter conditions. But if you notice the other retriever that gets created, it searches the same objects, but there is a filter condition saying grounding source ID equal to so and so ID. So what essentially this search index is saying is that this is only going to search on the fields or the files that come from this particular data library. So this corresponds to the data library ID. So we automatically create a retriever for each data library that you create, which is file based. So all of this setup, again, like it happened in the background. Typically, if you are implementing this for a customer, all you would do is you would upload a data library and you're done. Everything else happens in the background. Now, how would you use this? So I told you that a data library can be attached to an agent or a bot. So here I am in the agent screen, and I have actually a question that I want to ask the agent. This is again coming from my Spanish document. So let's say I ask the question, where are valet vehicles parked? So I'm asking it in English, but it has to search through a Spanish document. But notice it's not able to answer this question. The reason, it doesn't have access to my data library yet. So this tab over here called knowledge, so you click on that, and here you assign a data library to this particular agent. So here I'm going to assign the resort policies data library. And as I mentioned, you will only be able to assign one data library to a particular agent. Now, if you save, and let's now go back, refresh the conversation and ask the same question. So let's see what happens. The moment I assigned the data library, it now has the ability to go and search through those documents. And if you notice, now I'm getting a response saying valet vehicles are parked in a secure monitoring area, blah, blah, blah. Now, how did it happen? So if you notice, it has invoked one of the standard action that we have, which is called answer questions with knowledge. So this is a standard action that comes along with your service agents. And this standard action is the one that goes ahead and searches all the different results. And if you notice, there is an input that is sent, and this is a summary that comes back from answer questions with knowledge action. Now, this action is something that you can actually go and look at. In fact, just like in the previous demo, where we invoked an action which in turn invoked a prompt template to get me the results, the answer questions with knowledge standard action invokes a standard prompt template called answer questions with knowledge. So this is a standard template that we have that automatically gets created. And if you notice, the structure is very similar to the custom template that we have created, where it's going to have some context and a lot more instructions. Ideally, we are supposed to create it this way. For the demo, I just created a very light version of the prompt template. So here we have the question, and we are using a retriever over here. And the retriever is configured because it's a standard one. You won't be able to see a lot and configure a lot. But you can see it's the same thing. We are sending the query, we are getting the results back, and this prompt template is the one that powers the answer questions with knowledge standard action. So yeah, that's pretty much what I wanted to cover about Einstein data libraries. So essentially what we learned today is what is RAG and how do you set up RAG without a data library, essentially by creating the streams, creating search indexes, creating a prompt template, using a retriever inside that prompt template, and then using the prompt template wherever you want by means of agent actions or Apex classes and so on. Then we've seen what a data library is, which is a tool that simplifies most of this setup. You create a data library in which you can either upload a knowledge article or you can upload files, and you assign this data library to an agent. The moment you create a data library, in the background, we create the streams, we create search indexes, we create prompts, all of that is done. And once you assign a data library to an agent, we use the standard answer questions with knowledge action in order to get the results. So that was, in a nutshell, at a very high level, an end-to-end demo of RAG and data libraries. So with that, what I want to do now is see if you have any questions, which I'm sure there are a lot. So let me go ahead and see. Is it possible? So Sandeep is asking, is it possible to see the contents of index or chunk objects? The answer is yes, I've just shown it to you. The index, not so much, but from the chunk object, you will be able to query it. Then Jeff asks, if you need to view the link to the images or PDFs you are ingesting, would you still link to the source of file, or can you construct a link directly to the multimedia? That's a good question. So if you're using knowledge articles, what you can enable here is called show sources. which actually shows the citation in the sense that it actually shows you a link to whichever knowledge article has been referred to in order to get the result. So that's already there. And Jeff is also asking if we are able to like embed images, but like I said, images is not supported yet. We won't be able to do OCR, optical character recognition, and get the details. That's not possible. Then, so there is a user that asks this question: Agent can leverage only a single data library. Can we use this approach to create a custom prompt, leveraging multiple vectorized sources? So yes, the answer is yes. You will be able to create as many prompt templates as you want, and each prompt template can refer to a different search index. And all these different prompt templates can be added as agent actions. And you can give instructions saying that for this question, use this action, for this question, use this action. So an agent will be able to search through all of these different ones. Um, then Nick is asking a question: Can we add this agent on Experience Cloud portal, like self-service portal? Yes. The agent that I've shown you is actually a service agent, which can be exposed on any source like external websites, Experience Cloud, WhatsApp, SMS, and so on. Um, then Niket is asking a question: Does it use vector database with similarity search algorithm in the backend? Yes, all of this uses the vector database. We run hybrid search. What algorithm we use, again, you get to configure it when you're creating a search index. But yeah, eventually, yes, all of it happens in the background. Then we have a wonderful question: Are we able to compare PDF content with a contextual record data? So yesterday we were doing a workshop in which I had a policy document that talks about room upgrades. So room upgrades for different people. So typical hotels have this tier-based system where you're either a silver member, platinum member, and so on. And the policy document has the upgrade eligibility for different tier levels. So in yesterday's demo, I would encourage you to go back and look at it. What we were able to do is we ingested this PDF and we had the membership tier level on the contact record. So on the record, you have the membership level as silver, and the user ends up asking a question: Am I eligible for a room upgrade? So what the agent can do, it's going to first search your record, it's going to get your membership tier, and then it's going to run a search on the knowledge base and see if a silver member is eligible for an upgrade or not. So it's able to correlate both of them and formulate a response. So short answer, yes. Long answer, I would ask you to go and check the recording on Apex Hours. Towards the very end, we actually show you the end-to-end demo. Then we again have a question from Josh. Can you guide us on what you have shown today, impact consumption costs? So I cannot answer in terms of how much is consumed, but each time you ingest a file, each time you create that search index, it takes away from your data cloud consumption credits. So how many credits and all, I hear that there is a calculator that is available online, not officially though, but there is a calculator which you can use in order to calculate how many credits will be consumed depending on all of these operations. But yes, this consumes data cloud credits. So how much credits, again, I'm not able to answer, but I'm covered by the forward-looking statement anyways. So yeah, that is pretty much all the questions that I can answer live. If I was not able to answer a few questions, please take them to the Trailblazer community. And we are almost at time. We've been doing this for about 45 minutes. I think which is a good enough time. More than this, I think you will be stressed out. So with that, what I would do is show you a couple of closing slides. So you are welcome to connect with us. Like I said, if you're not able to answer any of your questions, please post them on the dev community, or you can even post it as comments on our YouTube, LinkedIn, and eventually we will take a look. And finally, I want to thank all of you for staying all the way through. I hope this session has been a good use of your time. And see you all again in another live stream that we keep doing every week. So thank you all and have a great rest of the day and see you again.